Hello there, my little dears. I can't even believe it. This is the next to last section of Algebra 1B that I will be teaching you. Hooray! And we can totally do it today. So in this section, we're going to talk about how we simplify radical expressions. We've simplified radical terms. Now we're going to look at whole expressions. In example 1 here, we're going to pretend that each radical kind of acts like a variable. So anything, if this were 5x plus 7x minus 6x, we would just add all the coefficients in front together. 5 plus 7 is 12, minus 6 is 6x. Well, the same thing is true for these radicals. 5 square root of 2 plus 7 square root of 2 minus 6 square root of 2. 5, these are all square root of 2, just like x. We can put those all together. So 5 plus 7 is 12, minus 6 is 6 square root of 2. Good enough, right? Let's try this next one. I've got 10 square root of 7, and then another square root of 7, 5 square root of 11, and negative 6 square root of 11. So we're going to put the things together that have the like radicals. So 10 plus 4 is 14 square root of 7. Next thing we need to look at is, can we simplify the square root of 7? Square root of 7 is a prime number. We cannot multiply it by anything but 1 in itself. So that's as good as it gets. And then 5 square root of 11 minus 6 square root of 11 is minus 1 square root of 11. Square root of 11 also cannot be simplified. Bears mentioning here, if you wrote minus square root of 11, that's the same thing, okay? And that's the answer. Easy enough, right? So you try letter C on your own. It's the same as part A. 3 square root of 2 minus 5 square root of 2 plus 4 square root of 2. They all have square root of 2 for their radical. So we can add all the coefficients in front. 3 minus 5 is negative 2 plus 4 is 2 square root of 2. And that's the answer. Example 2. This is only marginally more exciting because now we have to simplify the radical first and then see if we can combine like terms. So first, let's simplify square root of 18. I can make that. Sorry, dog's barking in the background there. Get rid of that. We're going to do it this way. I can make that 9 times 2, which is 3 and 3 and 2. So that's 3 and 2. So I can make square root of 18, 3 square root of 2. Now let's do, hold on, I missed something. There's already a 2 in front. So that needs to be multiplied by 2. Now we can move on to the next one. Square root of 32. Well, that's 16 times 2. And that's 4 and 4 and 2. So I got a pair of 4s and 2. So that's plus this 2 that already is out front. And now we can write this 4 square root of 2. Last but not least, square root of 72. We can make that 36 times 2. And that's 6 times 6 times 2. So 6 goes in the, or outside the radical, and 2 stays underneath. And there is nothing multiplied by that up front. So I'm just going to put a 1 there. So now we can multiply the 2 integers in front, and that becomes 6 square root of 2 plus 8 square root of 2 plus 6 square root of 2. Last step, we just add all the integers together because they're all square root of 2. 6 plus 8 is 14 plus 6 is 20 square root of 2. Hooray! Next one, same idea. You do it on your own. Go, 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 go. All right, let's start simplifying here. We can start with the square root of 54. I'm going to make that 9 times 6, and that's 3 and 3 and 3 and 2. So that's a pair of 3s. So 4 stays outside, and I've got 3 square root of 6. And then the square root of 24. That is 6 and 4. 6 is 3 times 2. 4 is 2 times 2. So that's 2 square root of 6 with this 2 still out front. Well, let's simplify. That's 12 square root of 6 plus 4 square root of 6. And that gives us, when we add it together, 16 square root of 6. I hope that's what you got. Pretty straightforward there. Now, when we multiply in these expressions, we're going to multiply the coefficients first. 3 times 2 is 6. And then we're going to multiply the radicals. 2 times 6 is the square root of 12. Now we have to see if we can simplify the square root of 12. That's 4 times 3. That's 2 times 2 times 3. So this is going to be 6 times 2 square root of 3, which simplifies to 12 square root of 3. Same thing is true for part B, except now we're going to use the distributive property. 3 times 2 is 6. Square root of 5 times square root of 5 is the square root of 25. 3 times 5 is plus 15. Square root of 5 times square root of 3 is square root of 15. So now if we simplify the square root of 25, we can the perfect square. So we've got 6 times 5. And then plus 15, can we simplify the square root of 15? 5 and 3, we cannot. That's as good as it gets. So we simplify and get 30 plus 15, square root of 15. All right, try part C all on your own. Okay, so we multiply our 2 integers together and get 14. And then the 2 radicals together and get the square root of 18. We need to simplify that if we can. That's 9 times 2, and 9 is 3 times 3 times 2. So we've got 14 that stays times 3 square root of 2. You got to distribute again. 14 times 3 is 42. Square root of 2. Yay! Last but not least, part D. 3 times 4, we've got, oh, just kidding. Do it on your own. All right, 3 times 4, starting over, is 12. Square root of 2 times square root of 3 is square root of 6. 3 times 6 is plus 18. Square root of 2 times square root of 2 is square root of 4. So can I simplify the square root of 6? That's 3 times 2. I cannot simplify, so this one stays 12 square root of 6. Square root of 4 I can simplify. That's 2 times 2. So the answer is just 2 there. So that's 18 times 2. So last simplification, 12 square root of 6 plus 18 times 2 is 36. Hooray! All right, this very last one, I don't care about. We're not going to worry about it right now. I hope this makes sense to you. It's really just combining the math that you already know with what we've learned about radicals. So let me know if you have any trouble. Have a great day.